Hi, this is Colin. Let's continue our DevSecOps journey. So far, we've seen SAML and Dependabot integration into our source repo. So we know that our dependencies are clear of vulnerabilities, or they would be if I fix the one that I leave open for demo purposes, as well as LGTM scanning has completed, and we don't have any major or critical alerts there. Let's continue with looking at some of the checks that have run against our pull request. There's several that have run here with the Azure Pipelines icon. Let's click on those details to go over to the details for that check. We'll click on the Parts Unlimited GitHub, which is going to show us the build that executed in Azure Pipelines. It's bringing some metadata in like tests. So we can see that there are 14 passing tests, as well as code coverage. So we have about 20% code coverage. Let's go and see the details for this. So I'll click on this link that says view more details in Azure Pipelines. Now that's going to open up Azure Pipelines for me. And here I get the full report. So if we look at the summary, we can see the commit that triggered this particular run of this pipeline. We can see the repository, 10th magnitude parts unlimited, which is the repo on GitHub. We can see when the pipeline was triggered, as well as for how long it ran. We can see work items that are related, or packages that are related, and we can see code coverage and test results in the widget at the top summary. If we scroll down a little bit, we get a visualization of various stages in this pipeline. This pipeline is a Yaml file, which I'll open shortly, and it's divided into various stages. We're first going to build and test our sources, and then we're going to deploy to dev, and then we're going to do a canary deployment before doing a full deployment out to production. And we've modeled this using multiple stages. Now within each stage, there are jobs that execute. So if I click on this build and test sources stage, we'll see that there's a build job, and here are all the steps that have run in that build job. Clicking on one of them, for example, build solution, will take me to the log for building that solution using MS Build. If I click on test assemblies, I'll get the logs for running unit tests. Let's go back to that summary. If I click on the tests tab, I'll get a link to the test results. Again, I get a summary of all the tests that have run. We have 14 passing tests. Now by default, this is filtered on failed and aborted tests. So I'm going to add past tests in here so we can see the details of the tests that were run. Now each unit test that is run gets an entry in this grid. Let's click on home index. Now, of course, this test was passing, so we don't have any error messages or stack traces. But if there were errors, we would see error messages and stack traces included here in this particular test result. We could even create a bug for this test result. So I'll hit create bug. That's going to open up a form that will let me create a bug that's linked to this unit test and this build and this run. If we look at the repo steps, we can see the path to the test file. We can see the build that was tested. Now, of course, there's no error message or stack trace currently because this was a passing test. But if that information was there, it would be added into this repo steps on this bug. We could hit save and close, and we'd have a new bug that someone in the team can go and investigate. If we click on code coverage, we'll see the code coverage results file. If I click on that to download it, it will download the Visual Studio Code Coverage results file, and I'll be able to open that up and analyze code coverage to see which methods and which lines of code have been covered and which have not. Clicking on environments, we can see which environments have been deployed to in this particular pipeline. We have a Parts Unlimited dev environment, and 2 jobs have run successfully against that environment. Now the environments are just logical constructs. Some environments can be linked to underlying resources. There's 2 at the moment. there's Kubernetes and virtual machines. We can also just create an environment that is generic, that doesn't have any knowledge of the resources in that environment, but can be used to supplement metadata about the environment, including checks and approvals. We'll see that in a later video. If we look at the summary for this pipeline, we can see that we successfully built and tested the source files, as well as deployed to dev. Let's click on deploy to dev. Now in deploy to dev, there are 3 jobs. The first one runs Terraform. Again, we'll look at Terraform in more detail in a later video, but I wanted to show the output of running the Terraform commands. Here we can see the actions that would be taken. This is the output of the Terraform plan. And the only thing that's changing is a tag that's being updated on the resources in Azure. The reason there's so little changes here is because I've already deployed this and all the resources have already been provisioned. So there's really very little to update in terms of infrastructure. That's for the SQL database backend. We'll see a similar plan and result for the web app itself, as well as application insights. And those are the 3 major components of infrastructure that we're deploying. The next job deployed the web application. So there's an Azure App Service deployment, which I can look at. We're then setting some sticky slot properties for slot swapping, which we'll see in a later video, as well as executing other commands like cleaning the test database for load testing. And there's another job which is going to run Selenium tests. And so you can see we've got integration tests modeled in the pipeline as well. Well, everything's passing, so that looks good. Let's go back to the dev site and refresh the home page. Now, if you remember from the first video, our discount was 3%. And you can see that we've updated the dev environment successfully to 6%. Let's go back to GitHub to the pull request. So we've seen the deployment has succeeded. One of my team members, Soccer Josh, also approved the changes. So now I can merge this pull request in. The other checks here are GitHub actions, which we'll cover in another video, and are not crucial to checking quality in this code. I'm going to hit merge pull request, and we'll confirm that merge. And that'll merge that code into master. While that's going, let's go back to Visual Studio Code and take a look at the Azure Pipeline YAML file. In my repo, I have a YAML file called Azure Pipelines.yaml. There's a name variable at the top specifying the name format. This is a semver version. 1001 is the first build, 1002 is the second build, and so on. There's a list of variables which I've defined at the top of this YAML file. There are 2 interesting variables here, the Azure Subscription and the VSTS endpoint. These are service connections that are defined in Azure DevOps. The Azure Subscription is a service principal connection to Azure for deploying resources. This lets me abstract authentication out of the pipeline so that an administrator can set that up for me without me having to know the passwords or credentials to connect to those resources. Let's have a look at the stages. The first stage is named build and refers to a build job template. We're passing in some parameter feeds like the Sonar endpoint and Sonar URL. This is for customizing the build job. The template will open up shortly, and that defines all the steps that we want to run as part of building and testing applications. The next stage is our dev stage. For this one, we're pulling in a variable group called parts unlimited Terraform secrets. Instead of hard coding secrets in our repo, we've put those secrets into an Azure Key Vault. The variables group allows us to bring those Key Vault secrets into our pipeline in a secure way. You can see the three jobs that are executing in this stage. There's a Terraform job to go and run Terraform to deploy, provision, and configure our infrastructure. There's a deploy web app job to go and deploy the web app. And there's a run Selenium job to run Selenium tests. The next stage also has multiple jobs. This stage has a condition. This condition means that this stage will only run if we're building code that comes from refs heads master. The jobs are again the Terraform job. This time we're targeting the production environment, so we're running that Terraform job against that environment. And again, we're using the deploy web app job to deploy the web application. This time, instead of doing a Selenium test, we're doing a deploy and route job, which is going to perform canary testing using web app slots. We'll cover that in a later video. Finally, with prod green, if we're happy with that canary test, we can swap and reroute traffic to the production slot. And there's a prod rollback just in case our experiment is not successful to route back to the original site. Let's look at a couple of the templates. This is the build job template. There are some parameters which we can pass in at the top. These templates are like functions that you call, passing in arguments that are specific for an invocation of this job. The pool we're using is Windows latest. That's going to spin up a hosted agent. This hosted agent is spun up and managed by Azure. It runs all of the tasks that we specify, and after that, it is destroyed. So I don't have to manage my own infrastructure. I can also create private agents if I need specific dependencies installed or just want to build on my own private networks. The agent is cross-platform and runs on Mac OS, Linux, and Windows. Let's look at some of the steps. This first task is pulling in NuGet 441. That's ensuring that I have a specific version of NuGet installed. The next task is doing a NuGet restore. It's using parameters that I've passed in, like the name of the solution, as well as the URL of the package feed, which in this case is Azure Artifacts. Next, I have a custom task that I've installed using the Visual Studio Marketplace. This is going to take the build number 100x and inject it into any assembly info CS file so that my assemblies have the same version number as the build number. It's great for traceability. Next, you can see a conditional task. This if statement will only run this task if the run sonar parameter is set to yes. There's also a condition that it'll only run off the master branch. This is because I'm using the community version of SonarQube, which only runs on the master branch of our code. There's a VS build task to build the solution, and I'm passing various parameters to the MS build args for that task. There's a test task that will test assemblies for me. There's some more SonarQube tasks for doing SonarQube analysis. Here I'm doing some inline PowerShell that's checking the quality gate of SonarQube and failing the build if the quality gate is failing. And finally, I'm publishing an artifact. That artifact is a compiled and packaged version of the web application that we can deploy in later stages. Let's look at one more job. We'll look at the deploy web app job. This job is slightly different. instead of having a job, it has a deployment. Deployments are environment aware. We've specified the environment by a parameter that gets passed in. This allows us to abstract approvals and checks from the pipeline to the environment, which we'll open shortly. Then there are various strategies that we can execute to deploy to this environment. I'm using a run once strategy here. I'm using an Azure RM web app deployment to deploy that package to the web app. I'm executing some PowerShell to manipulate some configuration settings that Terraform doesn't have the ability to set. Then I'm doing a SQL DACPack deployment task to run some inline T-SQL. This is primarily for load testing for my demo. Let's go and look at the service endpoints and the environments in Azure DevOps. We'll go back to Azure DevOps. And let's start with the service connections. I'm going to come into the settings for my team project and click on service connections. And then I'm going to click on the 10M client demo. We can see this is an Azure Resource Manager endpoint using service principal authentication. If I click edit, you'll see the information that I need to provide to set up one of these endpoints. We have to supply subscription ID, subscription name, service principal, ID, as well as key. Again, the advantage of service connections is that an administrator can set this up and authorize particular pipelines to consume this endpoint so that there's security and segregation of duty. Let's click on the Environments tab to go and look at the environments. And so far we've only deployed to the dev environment. So I'll click View Environment. And here under this drop-down menu, I'm going to select Approvals and Checks. Now we can see that the dev environment does not have any approvals or checks defined. We can see that there are several checks that we could add to this environment, including manual approvals, evaluating artifacts, invoking an Azure function, invoking an arbitrary REST API, querying Azure Monitor alerts, or even enforcing required YAML templates. Let's go to the Environments tab and look at the prod environment. This time, when I click on Approvals and Checks, we can see that I have a manual approval configured. I've configured myself as the approver. There are additional options that we can configure, like timeout options, as well as allowing approvers to approve their own runs, which I do just for demo purposes.